Hello everyone, welcome back to my channel codeWithKhan. So if you are new to my channel, please subscribe to my channel. Let's see today's LeetCode problem. So it is 3713 longest balanced substring level 1. So till now we have seen balanced array. Now we are going to solve for substrings. So let's read the problem. You are given a string S consisting of only lowercase English letters. A substring is called balanced if all distinct characters in substring appear same number of times. That means if frequency of all the characters, right, in a substring, if you choose any substring, if frequency of all those characters is same, right, frequency is same, then we call it as balanced substring. Okay, and we need to return the longest balanced substring. We need to return the length of the longest balanced substring. So let's see the constraints. Constraint is s dot length can be less than or equals to 1000 only. So it is marked as medium, but due to this constraint it will be very easy. Okay, and s will consist only lowercase English letters. Now let's take one example. Let's see this example. So what we'll do is, given this example a b b a c, so what we'll do, we'll generate all substrings possible. We'll generate all possible substrings, and then we will check is it balanced or not. Is it balanced or not? So let's see. We'll start from here. So first we will be having a. We'll starting I from here, j also from here. The first substring is 1. So we'll maintain a frequency array of length 26 because we'll having the 26 lowercase English letters. So let's take our frequency array also. It is marked 0 to 26 indexes. So first we encountered a, so let's update the a's index. So a index is 0, so we'll update here. Initially it will be all 0, so we'll update it to 1. Now we'll move further. We'll go here. So let's update b's index. Now let's move further. So what we have to do at every substring, right, what I said, at every substring we need to check is it balanced or not. So how we will check is it balanced or not? We need to check, iterate through this array, right? We'll have one loop and we iterate through this array and we'll check if it is not equals to 0, then we have some value there. We have some value, and if we have some value and all the values should be equal, right? So for example, in the first scenario, what is the first substring? When we have here, the first substring is a. Now we have updated that. So what are the values we will be having in the frequency array? This one, and remaining all are 0. So if it is 0, we are good with that. If it is a value, then all should be equal. So currently we have only one value which is not equals to 0, that is 1. So this is balanced substring. So we will take one max length variable. So currently it is 1 since we have a balanced substring. Now let's move our window. We'll go here and let's see this one. So we have b and we'll update b's frequency. Now let's see, we have 2 ones and remaining things are 0. We'll check is it balanced, right? We have 2 ones, so its frequencies are same. So we'll consider this as balanced. We'll update the max length. Its length is 2 now. Now let's increase its window. Now j comes here. Now we'll update the frequency of b. Now it will be 2. Now if we see, its frequencies are not matching now. A appeared 1 time and b appeared 2 times. That means it is not balanced, right? So what we'll do, we'll not update the max length. So still max length is 2 only. Now we'll proceed further. We go to j. So in this substring we encountered a, so we'll update a's frequency. Now if you observe, so we have 2 frequencies whose values are 2 only. So now this is balanced substring. So we'll update the max length to 4. How we can find the length? It is j minus I plus 1. So we'll update the max length. Now we will proceed further. We'll go here and we encountered c for the first time. We'll update c's frequency. Now if you observe, all the frequencies are same? No, all the frequencies are not same. So what we'll do, it will consider it as not balanced. So we will go further, and there is no index here, so we will update the I now, and j starts from I only. So again we will check if this b is there or not. So now we need to update the our array. Now frequency array will have 0 again. We will reinitialize the array. Now we'll start from here, and we'll check for, we'll repeatedly check by generating all substrings. Okay, let's write pseudocode for this one. So what we need to do, so we'll have one outer loop int I is equals to 0 to I should be less than n, and then I plus plus, and then for every time we will reinitialize our frequency array with 26 length. And now we'll start int j is equals to I2, j should be less than n, and then j plus plus. Now here what we'll do, first thing is we'll extract the character s dot caret of j, and then we'll update frequency of this character. Frequency of the character is update, we'll update its frequency. So how we can update, we can just remove character a from that character, it will give us the 0, right? It will give us the index. So how, if we have, if character is a, if we remove a from a, it will give the 0. If it is b, if we remove b from a, it will give us index 1. So like this we can use it. So here we'll, what we'll do, we'll do ch minus a plus plus. So once we updated the frequency, we need to check if it is balanced or not. So how will, so here we will check if it is balanced or not. What we'll do, we'll check if it's balanced. We'll write a separate method for this. If it is balanced, then we'll just update the max length, right? Max length will be equals to max of max length comma j minus I plus 1, and then it is fine. Now if we observe, so here we have written a method, right, which is balanced. Let's call it is balanced. So what it method does is, it will iterate the frequency array, right? Frequency array from I is equals to 0 to I should be less than 26. So it iterates 26 times. If we see the time complexity of this one is, here from 0 to n, here it is n, and here it is n, and here it is 26. So it is 26 cross n, which is 26 n square. Now can we optimize a little bit here? So instead of using 26, we can do it in order of 1 time. So how we can do that, let's see. Let's see how we can do that. So let's take one example, the same one, a b b a c. So we have this example. So while generating the substrings, we will keep track of 2 new variables. One is distinct count, like distinct characters count or distinct count, and then we have another variable max frequency of this distinct counts. Okay, initially when we are at a, so what is the distinct count? Distinct count will be 1, and max frequency of this a is 1. Now we'll move further, and we have encountered, okay, let's update the max length. So max length will also be, currently will be 1 only, because it is 1 only. Now when we go to b, right, I is here, b is here. Now we encountered b also, b is 1. Now what is the distinct count? Distinct count is 2, and max frequency of this is 1 only. 1 comma 1 is 1 only. So now what we need to check is, if this substring's length is equals to distinct count into max frequency. What is this substring count? Which is j minus I plus 1 is double equals to distinct count, which is 2, and max frequency, which is 1. Length is 0 1 1 minus 0 plus 1, which is 2, which is double equals to 2 into 1 2. So if this is equals, that means this is balanced, right? And then let's see the unbalanced substring. So now if you go further, j comes here and we'll increase the b's frequency to 2. Now max frequency is 2 and distinct count is still 2. So if you see, the length of the substring is 3, right? Length of the substring is 3, but the distinct count into max frequency is 2 into 2, which is 4. So 3 is not equals to 4. That means this substring is not balanced. So this method, checking if it is substring is balanced or not balanced, so we decrease its time complexity from 26 to order of 1. So got it? So using these two variables, we can decrease its time complexity. Okay, so now what will be the total time complexity? Total time complexity will be order of n square, and space complexity is, we are using frequency array, right? We are only using the frequency array of 26 length. It will be of 26, and these are constant variables. Okay, let's code for it now. Okay, let's initialize the variables. First we'll take integer array frequency, and then we'll use int n also. Now let's initialize them. N is going to be s dot length, then we'll take int max length for returning the while answer. We'll initialize it with 0 first, and then let's use loops. Int I is equals to 0 to I should be less than n, and then I plus plus, and here we'll initialize the frequency array with new int of 26. And then we'll take two new variables as I mentioned. One is for the distinct count, which will be 0 initially, and then max frequency, which is also 0 initially. Now let's generate the substrings. For int j is equals to I to j should be less than n, and then j plus plus. Now from I to j is one substring. Here what we'll do, we'll find the index first. Index is equals to s dot caret of j minus a. So here it is one index. Now we'll check if we are saying this for the first time, right? How we'll check? If frequency of this index is double equals to 0, then we'll update the distinct count. Otherwise we'll just update its frequency of index plus plus. After that we need to update the max frequency. Max frequency is equals to math dot max of max frequency so far and frequency of this current index. So once it is done, what we need to check? So we need to update the max length. So how we can update it? So we need to check the frequencies of all the characters in that substring, but since we used these two distinct count and max frequency variables, we can avoid that for loop. How? We'll find the length of the substring first with j minus I plus 1, and then as I mentioned, we need to check if this length is double equals to max frequency into distinct count. So if it is equal, then it is balanced substring. So we'll update the max length here. Max length is going to be math dot max of max length comma the length of the substring, and at the end we'll just return the max length. Okay, understood? Now let's run this code. Yeah, it is accepted. Let's submit this. Yes, it is accepted. So tomorrow we are going to see its level 2 problem. There we cannot use this n square complexity, so we'll see the optimal approach there. Thank you. If you like my content, please do like, share and subscribe.